Great. Welcome and good morning, everybody. We've still got a few people joining, but we'll get started and let them join. So welcome and thank you for joining us today. It's great to see so many of you interested in preventing plastic pollution through tackling avoidable plastic in your laboratories. We have people joining from across the UK and France, and possibly a couple of other countries too. This webinar will be conducted in English, but we will try to speak clearly and not too fast to help everybody understand. I'm Sophie Goodall-Smith, and I work for the Environment Agency in our Plastics and Sustainability team as a project manager. My colleague Lizzie Lewis is kindly supporting me in organising this event and assisting me today. We'll be using the Zoom chat for Q&A later, SlidePolls, and also a Google Doc form. So if you do have a second device, like a phone or a tablet, please have this available if possible. If you could stay on mute during the event, we'd appreciate it, and unless you need to come off later to ask a question. We will be recording this webinar so we can share it as a resource after. So please feel free to have yourself on your video or off as you prefer. Please type in the chat if you're having any technical issues, and Lizzie will try to resolve these. Thank you. So the agenda for today, just up on the screen there. We're going to start with me giving a bit of introduction about our Preventing Plastic Pollution project. The event will be 2 hours. We will finish by 12 p.m. We've got two great speakers. Firstly, Martin Farley, who's a Sustainable Laboratory Advisor at University College London. And secondly, Richard Lapham, who's a Sustainable Business Advisor at the Environment Agency. Our aims for the event are to outline why laboratory plastics are an issue, give you some tips on how you can reduce avoidable plastics in your lab, share some resources which will help you answer some of your questions, show a plastic-free commitment you can sign up to, and leave you with some ideas on actions you can take back in your laboratory operations. So the Environment Agency, you will have all heard of us, but you might not know all of what we do. We're an environmental regulator and an advisor operating across England. We're an executive non-departmental public body sponsored by DEFRA, Department for Environment, Food and Rural Affairs. And we work to create better places for people and wildlife and support sustainable development. Some of the things we have responsibility for are regulating major industry and waste, treating contaminated land, water quality and resources, fisheries, inland river, estuary and harbour navigations, conservation and ecology. And we're also responsible for managing the risk of flooding from rivers, reservoirs, estuary and the sea. We also have a national laboratory service where we undertake various analysis, water, soil, marine environment, waste, and lots of sampling and monitoring. So plastics, as we all know, they can be bad, but they can also be fantastic. The first example being medical context, research and science. As we all well know, this is really important, particularly as we've seen recently with the pandemic, and the role that plastic in PPE has been vital. So there's a big distinction between these kinds of necessary plastics and the types that can actually be avoided. So why are we concerned? Each year, an estimated 12 million tonnes of plastic enters our oceans. That's the equivalent to a bin truck full every minute. Plastic production has rocketed since its creation, and as you can see from the graph on the screen, it's increasing despite the growing awareness of the issues. I'm sure you're already aware that plastic never breaks down, it just breaks up into smaller and smaller pieces, and that means that every piece of plastic that's ever been made still exists unless it's been burnt or buried. Plastics have been found from Antarctica to the Arctic, on the sea surface, and in the deepest seabeds, including the bottom of the Mariana Trench. So some of the issues concerning plastics are ingestion. Plastics, particularly microplastics, can often smell and look like natural food, so they can be accidentally eaten. 1 in 3 seabirds directly feed their chicks plastic. This ingestion can lead to starvation and infection. Animals such as jellyfish, which can mistake plastic bags as food, it can cause them to be full, and that's the starvation effect. Some animals can also get entangled, as you'll see in the picture here. Items such as plastic bottle rings, fishing line and nets and bags can entangle marine animals. This can result in injury, infection, drowning, or even death. Toxic chemicals can also attach themselves to plastic, which means when it's ingested, those chemicals are too. A lot of research is still needed into this area, including links to human health. There is some evidence to link this to human health, but more research is needed. There has been found to be microplastics presence in food destined for human consumption and in air samples. So new risks may be emerging from microplastics and chemicals that we're not fully aware of yet. So there's a clear link between plastics and our climate emergency. Most plastics made from fossil fuels. As you know, they're non-renewable, which relies on continued drilling for these, releasing greenhouse gases. Once we extract them, they can't be replaced and will eventually run out, as well as being an important carbon store. Once we bring that carbon back into use and use them as energy or a material such as plastic, they're released back into the atmosphere as greenhouse gases. It's been estimated by the World Economic Forum that if plastic growth rate continues, it will account for 20% of global oil consumption by 2050. So that is pretty significant. Moving also to talk about plastics and climate change with greenhouse gases. It's not only the raw materials, but it's also the extraction, the transportation, often across the world, the manufacture of products and disposal of these that can release greenhouse gases. There's also scientific research that indicates exposure to light or photodegradation triggers the production of greenhouse gases. Polyethylene, which is the most produced and discarded plastic globally, is the most prolific emitter of 2 greenhouse gases, methane and ethylene, when exposed to ambient solar radiation by the sun. So on average, for every 1 ton of plastic material produced, used and disposed of, the total greenhouse gas emissions equivalent to 3.1 tons of CO2. I think it's quite apparent that by avoiding consuming less plastic and not switching to alternative single options or jumping just to recycling, we can lower our carbon footprint. So onto plastics in laboratories. These can be a significant amount of waste. In 2015, researchers at the University of Exeter weighed up their bioscience department's annual plastic waste, and they extrapolated, so extended that biomedical and agricultural laboratories worldwide could be responsible for 5.5 million tons of plastic waste a year. So that's an estimate, but it shows you that it could be quite significant. So what are we doing in the Environment Agency about plastics? Well, we have a plastics and sustainability team, which I mentioned myself and my colleague Lizzie on the call are part of. And we are secured some funding to link to a 3-year European Interreg project. We're in partnership with 17 organisations in France and England. And our project is focused on the south of England and north of France. However, we are sharing project resources and learning across the whole of England and France and more widely, for example, in this webinar. Our work is broadly split into 4 main categories: science, technology, engineering and maths, or STEM education, communities, work with businesses and other organisations, and also some internal work. We work to support communities internally, where we've created a cross-government plastics champion network with over 600 members across almost 40 government departments and agencies. And externally, we've brought together communities with a toolbox project to share learning and ideas across communities. We also work closely with river catchment partnerships, because we look at the sources of plastic pollution from the source to the sea. And we're working with our Environment Agency field operations teams to reduce the amount of plastic we use and increase the amount of plastic we remove from the environment. We've also been working with our own laboratories, which we'll move on to in a bit. And we like to share our experiences with other organisations to inspire them to reduce their plastic consumption, and also promote our Environment Agency as an exemplar organisation. So a key part of our project is engaging businesses and other organisations. We collaborate with business networks and partnerships, other organisations, local authorities, to share good practice and experience on minimising avoidable plastics. These include organisations in the agriculture sector, the sports industry, and with, for example, this webinar, organisations with the laboratories. We have finished creating resources, as I mentioned, with farmers and others. We've got case studies to tackle plastics in various areas, and we're also encouraging organisations to sign up to a plastic reduction commitment of some type. For some, that may look like a certification, others it might be an organisation's own commitment. And an example of that is LEAF, the Laboratory Efficiency Assessment Framework, which we'll be talking a bit about later. So another key part of our Preventing Plastic Pollution project is the STEM engagement. So very relevant to you, a lot of you on the call today, I'm sure. So we appreciate that engaging children and young people as the future custodians of our planet has never been more important than now. We're providing children and young people with support and guidance needed to encourage positive action and behaviour change in our collective fight against plastic pollution and avoidable waste. We've produced several outreach and engagement materials and run activities. So these are curriculum and non-curriculum linked resources, training events, live and online events, student and school awards, and we've worked with recognised education institutions such as STEM Learning and Countryside Classroom, Pixel and WWF. We've also set up a French and English school partnerships. We had our first event this week, and though a lot of the school and learning resources are available via our Preventing Plastic Pollution website, which we'll give you the link to later. So if you would like to access the resources and use those at work or outside work, then those are available. So other things that we're doing in the Environment Agency, we have a 7-point plan, and we aim to be an exemplar in our reduction and elimination of avoidable single-use plastics. So we work collaboratively to implement a regulatory framework. Could someone just go on mute? Thank you very much. Based on sound evidence and practical effective interventions. And we support other organisations and communities to take initiatives to understand better the impact of plastics as well. So we're expanding our evidence base, looking at circular economy principles, looking at increasing our waste powers, looking at microplastics in the water environment and in our supply chain, and raising that public awareness and working with others. On the regulatory side, we're taking steps to stop pollution causing harm, especially where we can clearly attribute the substance to a site or operator. However, it is sometimes hard to find the source of pollution. Unless we can make a connection clearly, it's not possible for us to take regulatory action. So an example of this might be plastic nurdles, like you can see in the photo there, which we sometimes find in the environment. We're working proactively with businesses and trade associations to reduce the release of those small plastic pellets. And we work with businesses and academics to investigate the types and quantities of plastics entering the environment. Industries we regulate include wastewater treatment, nuclear energy, and plastic manufacturing sector. So we also work with our own operational staff with training materials and looking at working activities and instructions. We gather ideas from staff and we seek opportunities to prevent plastic pollution during all our operational work. We have a sustainable business team, and you'll meet Rich in a bit from our team. And this slide just gives a summary on some of the achievements that we've had over the last few years on eliminating or reducing avoidable plastics. So some examples are within our catering and vendoring. We switched drinking water bottles for operational staff to reusable metal ones. We'll come on to more detail about our laboratory service later. There are also other examples around changing our furniture contract to be closed loop, zero plastic packaging, looking at our pension funds, and we also work hard on our own culture with our staff to engage people with plastic reduction guides. Other examples are around things like switching our milk bottles, looking at our construction activities and our supply chain and contractors, working with hotels and venues that we go to, and looking at excessive packaging of materials. We also have helped strengthen plastic industry standards to reduce accidental plastic through an operation called Operation Clean Sweep. So what can we all do? I'm sure a lot of you have seen this diagram before, called the waste hierarchy. All our everyday choices and decisions do add up. And the key thing to take away from this is to look at the best practice being at the top of the hierarchy. So primarily we want to avoid or eliminate the product or the packaging that we use. Working down the hierarchy as we make decisions, at the bottom being recycle. So the key thing to remember is to avoid, reduce, reuse, and recycle if necessary. And this is following circular economy principles as opposed to the linear take, make, waste economy, which will help reduce and eliminate avoidable plastic waste. So another key thing to have a think about is how we influence others. Our sphere of influence for all of us is a lot wider than we probably all appreciate. So this ability can be linked to likened to ripples that appear when you drop a pebble into a pond. They keep spreading and reach far beyond the point of impact. So by recognizing this influence, starting with ourselves, our immediate and then extended family, friends, neighbours, employers, and then widely that ripple effect out, there are ways that we can all engage audiences and individuals to inspire others and create conversations, create that ripple effect and influence more widely than our own immediate sphere. This can include having conversations with others, posting things on social media, thinking about events and gifts, and also just leading by example. So I think our sphere of influence is actually a lot bigger than we perhaps first imagined. So thank you. So what we're going to do is we're going to actually move on to our next speaker. Sorry, we're going to move on to our SlidePoll, get the agenda right. So I'll just get that up now so you can log in. So this is just a short poll to have a think about what organisations you're from, some of the issues you're tackling. So just bring that up now. There's a QR code on the screen. You can scan that with your phone or tablet, or you can actually join at slido.com #labs. And I'll just give you a few minutes to answer that first question, and I'll bring that up on screen for you. So just looking up on the screen there, we've got people from a really wide range of organisations, different universities, Oceanarium, University of Oxford, I can see, Southampton, Manchester, Ireland, Cork, Ifremer, that's one of our partners in France, Rouen University, CNRS is another partner in France, Queen Mary University of London, CFAS, from the University of Edinburgh, Reading, from Hamburg, Brittany, and the west of England. Kew Gardens and the University of Exeter, Kiel and Nottingham. So yeah, a really wide range of organisations. So welcome everybody, and thank you for sharing where you're all from. It's really great to see the wide range of organisations that are interested in tackling lab plastics. So thank you very much. We'll just move on to our next poll. So this poll is asking about what your main challenges when tackling lab plastics. So this would be great to if you could put that in there, and this should come up with a word cloud now of all the different issues and challenges that you are talking about. So so time, wow, time's really coming up there as a big thing. Disposal, how to dispose of plastics, where to start, how to convince people. There's also quite a few specific examples there of items that people are finding challenging. Making colleagues aware. Culture can be a challenge, keeping items sterile. Waste contractors that you're working with, which waste streams also. Working with suppliers, molecular biology, looks like a specific example, but pipette tips is coming clearly out there as a challenge. And the alternatives that people are thinking of. How to convince people. And the number one thing in the middle there at the moment is contamination. So a huge challenge for you is items that are contaminated. Great. And there's still a lot of, I'll just give that just a little bit longer for people to input their thoughts on this. So contamination is coming out a lot with sterility, disposal, alternatives, culture, time, convince people, lack of recycling schemes also, finding replacements. Great, thank you very much, that's really helpful. It's really, really good identifying your challenges. And I think a lot of this does start with identifying what the challenges are in order to overcome those. And during this event, hopefully you'll find some of the solutions to some of these challenges. Thank you very much. So we'll move on next to our next poll, question in the poll. And this is a pre-webinar, so I won't share the results. This is just 3 quick questions for you to answer, which are just going to show you, ask a few questions about where you sort of sit now, and we'll ask the same questions at the end of the webinar just to see how things have changed during the session. So thank you. I'm just going to stop my screen share, give you the chance to answer that. Thank you. Can see those answers coming in now, so thank you for doing that. It's great. Just give you a few more, couple of minutes to answer that, and then we'll move on to the next item in the agenda. Great, thank you everybody. So thank you for answering those polls. We'll now move on to our first speaker, and I'm really excited actually that Martin Farley is joining us today. And Martin is a sustainable laboratory advisor working at University College London, and he's got some really interesting resources, research he's going to be sharing with us, some really useful tips, and is going to also be outlining some of the details of the Laboratory Efficiency Assessment Framework, or the LEAF scheme. So Martin, would you like to share your screen? And thank you very much.
Awesome, thanks for that, Sophie. And what a turnout, it's incredible. It's great to see all these people here, and welcome everybody. Well, Sophie said welcome, but so my name is Martin Farley, and I work at UCL and King's College London as well. And to start off today, I thought I'd take a step way back and start with our net zero pledges, which we've heard a lot about in recent times. COP26, there was a lot of discussion around net zero, and obviously this is around the temperature increases of 1.5, 2 degrees, or potentially more. Now, to address this, we've seen a lot of companies and a lot of government organizations thankfully start to target net zero. The UK government put a net zero target for 2050. And you can see a third of the biggest companies have now set net zero targets. And a lot of the institutions that we work at as well. At UCL, we have a net zero target for 2030. And at King's, there's a bold one for 2025. And possibly one of the most exciting ones on here is the UKRI target of net zero for 2040. If you conduct research in the UK, chances are you're quite familiar with UKRI. Their sustainability strategy was developed by NERC, which is one of the research councils under UKRI. As far as I know, I think this is the first, the biggest major funder to really set a net zero target. So, it's really interesting times for looking at how we can make science more sustainable. And it's really helped move the needle quite a bit in terms of action on the ground. I have to say, one thing that is worth pointing out is that most net zero targets will typically focus on energy consumption on site. They don't always include the embodied carbon in the materials that we purchase. Now, the reason for this is in part because it's just really hard to set these targets. When you hear these net zero targets, they're always spoken about in CO2 or CO2e, carbon equivalent, CO2 equivalent. And at UCL, we did an estimate of our total carbon. And you can see that this little blue slice here is our energy consumption on sites, which is around 12% of our total carbon emissions, with the majority of our emissions coming from what we buy. And this says lab equipment here, but it should say really lab supplies. And a lot of this essentially comes from all that we buy. Now, it's very tough to make targets and to establish targets around our what we call scope 3 emissions, or all the stuff that we buy, in part because we just don't know the real amounts. If you buy a piece of plastic in a lab or whatever you buy anywhere, typically, you don't really know about what we call the embodied carbon of that material. You can find the energy consumption quite easily and quite readily, but it can be quite a challenge to find the embodied carbon, so the carbon that was required to manufacture that item that came to you. And really, that's the elephant in the room when it comes to our emissions. So, we had an attempt at quantifying it at UCL, but more work, much more work is needed in this space, and I'll highlight how that can be done and what work has gone on. Yeah, it's you know, it is the elephant in the room, and we need more action in this space. And you can see, you know, labs actually really are responsible for about half our emissions at UCL, according to these estimates. Labs are responsible, I should say, for half our energy consumption. So when we add this up, it gets to about half of our total emissions. So that's kind of why we're talking about science facilities. And of course, why we're talking about plastics is this big purple part of the pie. So it's really tough to know how to act in this space. And I think a direction that we're going is this. And this is, if you drink coffee in the morning and you've switched from traditional cow's milk to oat milk, you might have seen Oatly. And if you look in tiny print there, you can see that they've put a figure, which is the kilograms of carbon per CO2e. So that's tons of kilograms of CO2 equivalent per kilogram of the milk. And so I'm highlighting this because, you know, you won't find this on most products that you buy, but really that is kind of the direction I think we need to go. When we purchase items, we need to know about the total footprint of them, so that we can identify where the big impacts are, albeit we do have an idea already. But that quantification is really needed in a standardized manner. And, you know, it's going to take some time for that. You know, it is very early days, and Oatly did this because, you know, they obviously are aware that their emissions are much lower than traditional cow's milk. Now, there are some companies that do great things around this space, and I wanted to highlight that, and I'll also highlight some of the less good ones. You know, NEB is a company that produces a lot of consumables and kits for, particularly kits, sorry, for science, and they'll actually take back their packaging and actually reuse it. That's the only scheme that I know of in which a company will take back their entire packaging and actually the ice packs as well. If you've ever walked around a research lab, I'm sure you've seen shelves full of boxes and packaging because people receive a lot of deliveries. And this is obviously genuinely a good initiative because it means that things are reused. And as I understand it, they use the same trucks that come in and out. These are collection schemes for solvent bottles. Now, this is mostly for glass bottles, but I wanted to highlight it because it was a clear reuse scheme. And that's kind of, you know, the ideal is that when companies really reuse items as they were, it allows for, you know, avoiding that loss of the embedded carbon in the glass, plastic, and materials. And that's companies that are doing good things in this space that I think those schemes are good. They're not everywhere, of course, but it's up to us as well to manage those on our sites. And StarLab has done a fair bit on plastic recycling, and a lot of tip companies have tried to do reloadable tips, which is of course good. But you know, as you can see from the poll, this is not everywhere. A lot of companies do not offer these schemes, and you know, there are, you know, companies as big as Thermo Fisher. I know it's difficult for them, but more sustainable packaging and take back schemes is very difficult for them, as I understand. But it is the direction that we do need to go with the amount and volume of science that we're doing. This is an example I thought I needed to highlight because it's a real kudos to the company for doing this. It's not, you know, the Granova Tip Washer is a piece of equipment that exists now, and it's an example of a piece of equipment that I think is where we're going. We can see more pieces of equipment like this coming onto market, where people are essentially highlighting how to actually reuse items. And this is a tip washer. It doesn't wash filter tips, and it's not the cheapest piece of equipment, but I think the fact that they've created it shows that they're aware of the issue, and it's highly commendable that they've done this. Of course, I need to mention most of the plastic in your tip box is contained within the box itself. So like many labs are doing, I'm sure, if you're reloading your tip boxes, that saves the most on plastic anyway. So with the filter tips, for example, if you reload the tip box, that will save on the majority of the plastic with the tip box. It doesn't deal with the tips, admittedly, but you know, it does get most of the way there. So, you know, it's kudos for doing this, although there are some considerations you have to make with purchasing this piece of equipment, which I won't get into now, but I think it's just great that more types of equipment like this are coming onto market. That being said, there are a lot of schemes out there which are not necessarily as clear. And one example, I'm not going to name the companies, but this is one that I saw where they said, you know, make your gloves green. And essentially it's about biodegradable gloves, which, you know, it's clearly being marketed as something for laboratories, but you know, the reality is most labs cannot put their gloves into composting. It cannot be degraded in landfill, so that inclusion is not really applicable in most lab spaces. Most lab facilities can't deal with a biodegradable glove. And to be frank, it's a component, as I understand, that they put in their glove, which can increase the speed of which it degrades within landfill. You know, I think it's great that, again, I don't want to be too harsh on them for this effort, because it's great, but equally, we need that type of critical thought when looking at these schemes. The other schemes that we see are a lot of recycling schemes, which are good, but I think we need to ensure that what we're doing with the schemes is better than what we were doing in place already. Energy, most often gloves, for example, are burnt for energy recovery, and that's of course not ideal. But we need to ensure that the schemes down the line are a lot better, and recycling is not the most efficient always. It's not the most efficient process. And so, you know, reduction and reuse is paramount. I should mention at Granova Street Hospital in London, they've done some great work on reduction of glove use in clinical settings, which I thought was really interesting. So I should recommend them as having done great work, and just allowing some critical thought about when you need a glove, when you don't need a glove, when a glove can be reused. Yeah, I just thought that that's a balance, and it's not to point a finger too much at them, but it is that type of critical thought we need around these schemes. When a company promotes something as being more sustainable, I think we should be able to ask for the evidence that it is, because, you know, we need to support these things on site, and sometimes they cost more, and we need to manage them on site. Now, this one I'm being tough on. I'm not going to say the company, but this is an example of what to really watch out for. This company was marketing this single-use mouse cage as more renewable. You know, you can see the symbol there at the bottom right. They were marketing this because of that balance between energy consumption and embodied carbon, which is, you know, they're saying that if you use their single-use cage, you don't need to run your autoclave as much because you're not washing the cages. But actually, overall, that leads to a massive increase in carbon emissions. So the reason I'm having a bit of a punch at this is because I think that is kind of wrong, to be frank. I don't think this should be marketed as a sustainability opportunity. I think it should be, you know, a bit more transparent. But that's why, when you see these things marketed to you, you have to really ask yourself, where's the evidence? Have they considered the whole system? And is it really better than what we're doing in place currently? And so it is slightly the wild, wild west in terms of marketing around green initiatives. So it is, you know, if they're not telling you figures in kilograms of carbon and impact, and there's not a clear benefit, then I think you do need to start questioning whether it's true or as good as we think. Now, to highlight these uncertainties is, you know, we need more research in this space. We really do need more research, and I think it's great that the Medical Research Council just put out a grant which closed a few days ago, but they put out £1 million for research in this space. And it's just exciting because it's one of the first times that I had seen a grant like this. And, you know, it just shows that the Medical Research Council and UKRI are taking this topic extremely seriously, and they're taking their net zero target very seriously. For those who aren't aware, Medical Research Council, MRC, is a research council under UKRI, who's that organization I mentioned before, who set a net zero target for 2040. They work alongside NERC, for example, who wrote this strategy. So it really shows that you know, the big bodies are taking this seriously. I'm really excited to see what comes from this. You know, I'm just going to mention a paper that I was working on with a colleague, Benoit Nicolet, who's a great guy based in the Netherlands and a researcher. And we put out a preprint recently because we hadn't really seen research that just, you know, it might be obvious some of this, to be frank, but we were just trying to look at the impacts of reuse of labware in terms of carbon emissions, but also financial costs. And this is a preprint that we put out, but I'm going to share the preliminary results because we've just sent it for publication. So you know, it'll come out soon, but I still want to share these results with you because I hope it provides some helpful evidence for this. So first of all, we looked at, you can see here what we looked at. These are the factors that we tried to include when we were looking at single use versus reuse. And this is in terms of the carbon emissions when we were factoring these things. And you can see that the majority of the emissions associated with single use really derive from the production. It is the production of the plastics, which is coming from oil and transported over, which has such a high impact. And whereas it's a bit more of a balanced, you know, the autoclaving can take a lot of energy here in terms of the footprint of reusable items. And what we showed and found was that, and this is maybe expected, but reuse led to much lower carbon emissions. And it wasn't just reuse of glass, but it was reuse of plastic as well. You know, some plastics may be autoclaved and washed. And so, you know, anytime that you're actually reusing items, you are lowering their carbon emissions overall, despite the use of that autoclave and drying and washing process. And especially as you use more, you're going to just see those impacts increase. We did this for quite a few different consumables, and as expected, we found similar results, which is that as you used more, the single-use items emissions would greatly increase, and the reuse you know, was just not really comparable. We can see quite a significant fold increase in emissions with the different items that we use. By the way, we tried to target items that we know you could immediately start to reuse in your lab. You know, Petri dishes, Pasteur pipettes, those are items which you can still purchase in glass form, or you can wash as well. So you know, we were trying to make this an applicable paper to the immediate. Last bit of results is, I want to say, is just look at costs. In terms of costs, we found that things were actually quite comparable. We found that in terms of costs, it was either a comparable amount of cost, or it was actually sometimes cheaper to reuse the items on site. And despite we tried to look at the costs where they originated from, most of the cost in single-use items really just comes from the purchasing, and of course consumable prices are increasing. But you know, the reuse, we found that the cost came from a variety, and salary was a part of it. We tried to include salary, but overall it led to savings. And of course, these are savings that would be that the lab would receive. You know, this is something that the lab genuinely would start to save on. So in this sense, we think it's a benefit for the most part for labs, not only in terms of carbon emissions, but in terms of costs. And this is just going to be increased as consumable prices increase, although energy prices are increasing as well, I should say. Anyways, this is an example of you know, this in action. This is from the University of York. These are some folks who started decontamination stations, and they're not the only ones to do this, of course. I'll mention some other examples, but you know, they were just looking at providing facilities for people to soak and to wash things like Petri dishes and otherwise, which would have been single-use plastics, to allow them to be reused. And often they would get the question, you know, is this actually better than what we're doing? And overall, you know, the answer is yes. So more research is needed in this space. Obviously, I saw a paper actually come out this morning, which I wish I'd been able to include, but just highlighting, sort of a call to arms around in vitro work within labs. And more research is definitely needed. We don't know the life cycle assessments of so many products and processes. There hasn't been necessarily quite the investigation on contamination between these different steps. There has been in the clinical world actually a bit more, because the implications of contamination are sometimes much starker if it involves patient safety. And there are some papers around this which have shown that reuse is possible in the clinical sense. But more research is needed in this, and it's exciting to see that the MRC put out funds for exactly that type of research. But we can see that we need action now. The IPCC report, the update came out quite recently, and as much as we need more research, in a lot of ways, we know what we need to do in some ways. We don't always know how to do it in the best ways, but to be blunt, we need to promote reuse and reduction. I put in a picture of an old lab, and I have a colleague who visited some labs in Japan and was saying how they noticed that a lot of the labs still and top research labs were functioning with and it was life science labs, not just chemistry labs, were functioning perfectly well with a lot of glass, a lot more glass than we would see in our Western labs, which I thought was quite interesting. And we hear examples of reuse in labs where, a lot of labs, for example, during the pandemic, there was shortages of consumables, and we saw examples of reuse that otherwise, we wouldn't have expected. And some labs said they could never started to reuse things, and necessity is the mother of invention in that sense. But we know we need action now. So while we do need more research, we definitely need to take actions in this space. I would argue that we need standards in this place immediately, almost, and if not yesterday. When we try to make labs and science safer, we work against a common standard that the Health and Safety Directorate in the UK and most countries provides a central standard that people self-assess against. And you have to meet these standards when you're conducting research. If you apply for grants in the UK, you have to take actions around gender equality. And there's the Athena Swan program, which was mandated with grant funding for a good chunk of time. That I would argue is how things improve drastically quickly. And it's how we take a leap forward. Sustainability, for some reason, we've allowed to be voluntary, and we leave everybody to their own devices to essentially come up with their own actions. And it's really challenging, especially in specialist areas like labs. And so for that reason, from UCL, we've been working on something called LEAF, which is our standard in sustainable lab operations. Essentially, it's a set of criteria and calculators contained within an online tool that looks through all the actions that you can take around sustainability in a laboratory. It's really focused at people that work in labs. It's not focused on the building, the refurbishment. It's focused on what you can do in a lab facility as a scientist, a technician, a PI, a postdoc. The criteria are broken up into bronze and silver categories, bronze, silver, gold, and it's a user-led initiative. We're working with users to try to understand the best actions that they can take, and trying to produce a tool that is as easy to use as possible, but enables action now, because we do need that action immediately. By the way, I should say, we have calculators in the tool that allow you to estimate your impacts. Not on everything. Plastics is one area that is extremely challenging currently to make a calculator, in part because of what I was mentioning before. The embodied carbon of most of the materials that we buy is just not available. And so we do have to estimate it, albeit we are working on this and hope to have plastic calculators embedded within it soon. A headline I think I should say is that those who participated in LEAF during our pilot reduced their overall carbon emissions, they saved on money, and And so often, I just want to mention that because often sustainability is viewed as a cost. And I would say that, whenever you promote actions like reuse and reduction, and making things last longer, that typically will save on costs, albeit sometimes it does require more time on our part. And we do have to consider that amount of time that it takes to do these things. This is a poster we put together featuring Saroj from Oxford, and she's really an all-star when it comes to reuse. I can't emphasize that enough. She's someone who's taken so much time to allow consumables to be washed, and she does a lot of the washing as a lab manager and postdoc at the Dunn School of Pathology at Oxford. But it takes a lot of time and on her part and others who support her. So, yeah, I just think she's such a great example of somebody who's taken this on and really pushed it herself. And actually, what she's doing is very much, I'm sure, saving the Dunn School of Pathology a fair bit of money, but also significantly reducing their overall carbon emissions. While energy costs might be going up, the amount of carbon associated with the energy you use typically is going down. And that has to do with more renewables coming on. So, if you use energy tomorrow, it will use less carbon than it did today, which means that washing just becomes better and better and better in terms of reuse. Back to leave, I'll just say is that these are some examples. This is not the full framework, but this is just the type of things that we ask people to do. And it's a shortened version. There's more guidance in the tool, but in case you're curious, what are we asking people to do? This is the type of actions that are in the system, but there's a bit more, and there's the calculators as well. So LEAF is now online. It's been online for a year. Bristol became the first institution that we know of to get 100% lab uptake. I'm going to mention another one in a second, but I think we're at 60 institutions now from 10 countries, which is amazing. It is, as I understand, the biggest Green Lab program in the world now. And we have, I think, 1,400 users from over 830 labs, although that was from a few days ago, and it seems to go up quite rapidly with all the enthusiasm, which has been fantastic. There's too many to name, but there's just so many great folks, and we're just providing the tools. It's obviously the people doing all the good work here. We've been supported by UKRN, which is the UK Reproducibility Network, in recognition that reproducible science is the most sustainable science. Yeah, I'll leave that one for there. But yes, so things are going well. We've put a lot of resources out, and this is actually what I want to talk about in a little bit more detail, because these are the tools that you can access to enact actions now. You can find these on our website here, but we've put out, for example, a lab plastic recycling poster showing which plastics we can recycle within UCL. And this is, to do this, we had to engage our waste supplier to understand which ones they would accept, and came up with guidance on how to do that. This is an exercise that institutions would have to go through yourselves to ensure that the materials can be recycled. So we checked it with ours. I think someone just, if possible, could go on mute, sorry. But we also have an exit policy, because when people leave the lab, they often leave materials behind, not just in the freezers, but in cupboards, consumables. I've seen a lot of consumables have expiry dates sometimes, which yeah, is well, debatable if it's contained. But the point is, we need to track materials of departing staff and students so that they don't just sit someplace and get thrown out. And probably the thing that's the most useful, I hope now, is this, which is our Green Lab Consumables Guide. And this was essentially a guide, and you can see the different sections that just goes through all the actions that we've learned of from our LEAF users that you can take now to reduce single-use plastics and consumables overall, because it's not just about plastics, it's about all the consumables that we use in such high volumes in labs. We're trying to update this annually, but it's an open resource. You can see quite a few authors on it. If you want to contribute to it, you're totally welcome to. But we've done this because we're trying to enable action immediately, even for those who don't use LEAF. So you can find that guide, and it was produced with a lot of folks from Lean, which is our Green Lab network in the UK. And if anybody's on Lean, feel free to put that in the chat, and or any of these resources I'll put in the chat afterwards. We also have a poster, and this is just highlighting some things to think about, but this is not, I think, quite as useful, I would say, as maybe this guide here. Do you require gloves? That did get some double take from our health and safety. Although I did have a chemistry professor say, actually, why do we use gloves as much in chemistry? They all have, they're all permeable to chemicals within a certain amount of time, and you react quicker when you don't have gloves, although that is debatable. So anyways, I'm not gonna, I thought it was an interesting take on gloves, and anyways. These are some of the actions you find, and these are some of the obvious ones you might expect and clear ones, but I think they're great to see in action, and they're real examples from UCL and King's as well. Glass pipettes, they don't need to be single-use plastic. They can be washed, reduces carbon emissions, saves costs. Falcon tubes, you don't need to use a single-use plastic Falcon tube for everything. A buffer can be contained within, for example, a glass tube. And this, again, can lead to long-term savings because you're not paying for these expensive consumables. Watch out for the packaging associated. This was a great example that they found of overuse of polystyrene within the tubes that were coming in. And this was not intentionally done for plastics, but I loved it because it inadvertently was one, which was just that, they were running out of space and they wanted to go for a new type of microtube holder for their freezers. So they just minimized the size necessary, which was a great example. This is not at all the examples you'll find, but these are some of the ones and that we had nice examples of, but the sizing is a really nice one. If you don't need a 50 ml, can you go for 15 or smaller, etc. And these are just really easy ways to reduce your single-use plastics. Well, that one actually takes, you do have to change your system a little bit. And of course, it does take time. I'm not trying to say everything is easy. As Suraj from Oxford can testify, it takes a lot of effort to ensure this reuse is there. On that note, we recognize the importance of our technical community and lab management staff, who historically, in some decades, were underinvested in, but actually are one of the most valuable resources of all in labs. If you were a PhD in a lab or a student trying to figure out how to use a piece of equipment, I bet it was the technician who showed you how to do it in the most sustainable and efficient way possible. And they're the ones who often are tasked with washing things and making sure that our labs run efficiently. In that respect, we've been running a pilot of LEAF with 5 institutions across the UK, specifically through the technical communities within our institutions. We're going to put a report out on this, but I think what we're trying to highlight is just how important technicians are to our net zero ambitions. We cannot do this without them. They are absolutely vital in this, and we need to invest in them more. We need to ensure that they have the training and resources, training and support, that they're not asked to overwork, essentially, to allow us to hit our targets. And one of the challenges is that sometimes is the funding models, for labs. I recognize that a PI will pay for their grant, will receive and be in charge of the grant, but it's the technicians sometimes that are funded centrally from different budgets. And so as institutions, we do need to look at our central facilities that are provided. And if we're going to install things like, tip washing machines, essentially, that's the type of investment we need from institutions centrally, is into those wash facilities to be supported appropriately with technical staff that can have sufficient time and are not overworked to allow us that reuse culture and going back to labs of old in some ways. That really is the way to go. I'm almost done, sorry, but I'll just say the MRC announced that they were using LEAF in their facilities, and the University of Exeter just got 100% uptake of all of their labs, which was truly incredible. So I think Danielle is on the call actually and deserves a real round of applause, because that's the second institution in the world that's managed to get 100% of their labs accredited. And lastly, I just wanted to say it's been just incredible seeing all the goodwill and amazing stuff that people have done with Leaf. You know, we launched it online a year ago. We piloted it for a few years, but my gosh, you know, we saw at the University of Copenhagen in their elevator, they were promoting Leaf, and there was just, you know, Nicolina deserves a lot of credit, who's the one leading there. And the British Antarctic Survey managed to get a lab accredited in the Antarctic, which was just incredible. And you know, it really gives me motivation that, you know, scientists want to take action in this space, you know, and so we need to enable it further. And hopefully some of the resources that I've shared today can help you. And if interested, please do get in touch around Leaf. In conclusion, please do consider Scope 3 emissions. Think about it when you set your targets. Don't just think about energy. Watch out for marketing. Greenwashing is real, but there are a lot of good efforts as well. So, you know, we need that critical assessment of these things. We need more research in this space, but we need to act now. We really need to take action in this space. So check out our resources, sign up to Leaf, and get in touch if you're interested for anything else. You can find my email there. But I just want to say thank you to everybody for joining today. Hope I haven't run on, but especially thank you to Sophie and Lizzie for putting on today's event. And I will hand over now to Richard.
Thank you, Martin. That was an excellent presentation. Lots of really useful information in there and tips and examples. So I hope everybody's found that really useful. Thank you. So I'm just going to share my screen again, and we're going to move to our next speaker, who's Richard Lapham, and he's a sustainable business advisor working at the Environment Agency. So just one moment, and I will just bring up that slide there. There we go. Just one moment. Okay, there we go. And excuse me, I'll just move to your slides, Rich.
Thanks.
There we go. Okay, so over to you, Rich.
Right, thanks, Sophie, and thanks for that, Martin. That was a really good presentation there. I mean, certainly the labs, we were on the kind of trial for the Leaf. Leaf is a really good thing. I mean, COVID got in the way, so we've kind of paused it in our labs, but hopefully we'll, now that it's kind of COVID situation is easing, we'll hopefully revisit that and get that back on board and get that back up and running. Right, so my name is Richard Lapham. Like I said, I work in the sustainable team for the Environment Agency. We're a small team, about 30 staff, and we advise on and monitor our environmental performance, just to make sure we're setting an example for those we work with, those we influence, those we regulate. I also support our operational teams on the ground to make sure we're seeking the best outcomes for nature in all the work they do. We also have on the EA to become more sustainable through our net zero ambition and our wider net zero targets. So my screen's gone there, but it looks okay. Yeah. So our wider sustainability plan. So we've got, it's called Emission 2030, and this plan seeks to tackle kind of climate emergency, optimize our use of resources, benefiting people and communities, and deliver an environmental net gain. So, but today specifically, I'm going to talk about the subject of waste, and in particular, lab waste, lab plastic waste. So go on to the next slide, please. Yeah, so a little bit of background. I'm going to go through a bit of background why we started on this journey. Then we move on to kind of how big the problem was. Spoiler alert, it was a big problem. And then I'm going to go on to some case studies with some examples of what we've done within the EA's National Lab Service to try and reduce single-use plastic. So go on to the next slide, please. Right, so like I said, the background, we use a lot of plastic in labs, but do you know how much you're using? Do you know how much you're sending to waste, how much waste you're producing? Going back, say, 10, 15 years, the agency had a really good handle on what's happening in our offices, but not so much in our labs. So in the EA, we set ourselves some challenging targets in 2015. It was our first kind of emission statement, and we kind of challenged ourselves to kind of meet some of these things by 2020. So we had the kind of the normal things you'd see in environmental plans, things like reducing carbon, kind of reducing the amount of paper we use, the amount of travel we do, look at how much water we use, trying to reduce that. And waste was quite a big one. So waste for offices, we had a target of no more than 25 kilograms of waste per person per year. So if you think you had an office, say, of 100 staff, we'd aim to have a kind of yearly waste total of no more than 2,500 kilograms. But that target wouldn't really work for labs because we knew we kind of produced a lot more waste, but we weren't really sure about how much. So we had a slightly different target for our labs and our operational side of things. And the target was to reduce the amount of waste we produce by at least 20% and have net zero waste to landfill where it was technically feasible. So go on to the next slide, please. So in the let's go back in 2015, we had 3 main labs. So the lab in Leeds, Nottingham, and Starcross, which is near Exeter. And in 2015-16, we produced just over 170 tons of waste. So that's a huge amount of waste that we're kind of producing. So if you think back to earlier, like I said, when they're looking at offices, where you're looking at kind of trying to produce less than 25 kilograms per person, if we did the same target for labs, that'd be looking at around 800 kilograms per person. So that's a huge amount of waste that you're kind of producing in the labs. So now we kind of did that kind of almost as a kind of a baseline, so kind of identified how big the problem was. So the next big step was trying to improve that. So trying to reduce our waste. So getting out the waste hierarchy, like it's sort of been mentioned, kind of avoid, reduce, reuse, recycle. But then you've got the kind of the blockers you come across. So what were the kind of blockers? Things like, what would staff kind of do? Staff don't really like change. It's kind of, so we've always done it like this, or it's too difficult to change, or this way's cheaper rather, or haven't got the time to make the changes. There's loads of kind of reasons that kind of get thrown up to why you can't make improvements. And a big one of those is probably kind of lack of an awareness. So go on to the next slide, please. Right, so this is how we did. So towards the end of 2017, our sustainable team, we purchased a plastics ocean video. So we purchased both the kind of full film and a shortened version, the kind of 30-minute version. And the sustainability team went round the whole of the EA, kind of laying on screenings for all staff to kind of watch this movie. And I did the same for lab staff. I had numerous kind of showings, went round each of our sites. I kind of had talks and discussions highlighting the plight of kind of what happens in the oceans and with the single-use plastics. And then not long after that, the Blue Planet 2 aired on the BBC. That's kind of again highlighting the plight of oceans and due to plastic waste. So this was a big shift in mindset for staff and a big wake-up call for everyone. So you can see there all the sort of things we did. So we've got quite a big reduction in our plastic use. So we had a kind of target of 20%, but we managed to get it down to well over 50% reduction in our waste. And a big part of that was plastic waste going from 20 tons down to, in 2021, down to about 166 kilograms. So it's a big reduction in the amount of plastic we're kind of using and having to either recycle or get taken away as hazardous waste. We go on to I'm going to go now onto some examples of the sort of things we've done within the labs to try and reduce plastics. So this is the first one. So this is one of the tests we do in the lab. It is kind of for our bathing beaches, and we do a test for E. coli. So you just get you measure a volume sample, you filter it through a 0.5 micron membrane filter, and then that filter is transferred onto a growing medium, and then that's kind of incubated to kind of grow the E. coli. So our old method, we used to use a medium, I think it's called lauryl sulfates, and then you'd get E. coli's growing and you recognize them by the yellow colonies because the medium itself would have a kind of a pH indicator in there. And when E. coli grows, one of the things it does is it produces acid. So you get these kind of yellow colonies you can count and pick off. But that's only a presumptive test. And so you had to kind of do a lot more testing on those kind of bacteria just to make sure they are really E. coli. So you have to use an extra 10 55 centimeter plates and an extra 2 90 centimeter plates just to confirm the positive results. The new method kind of moves away from that traditional agar and goes over to a chromogen agar. And there's an enzyme that's kind of specific to E. coli cells, which target the chromogen. And this releases a chromophore, which is colored and kind of builds up this kind of blue, greeny blue color within the cells. So you can see them on that picture there. So that's the kind of E. coli growing. And because that is kind of specific, that enzyme is only in E. coli to be able to break down that chromogen. You get its own E. coli that produces that color, so you don't have to have all the conformation steps. So that means you can reduce the amount of plastic waste we do. So in this example, we're saving over 50,000 polystyrene plates every year, and similar sort of number of inoculation loops. So that's kind of reduced the amount of plastic we used in that kind of method quite considerably. What's the next example? There's another test we do within the National Lab Service is looking for kind of trace metals in seawater. So things like copper, zinc, cadmium, lead, nickel. The problem with seawater is it has a lot of interferences. So most methods, you'd have to do some sort of pre-analysis step before you could analyze the actual metals you want to look for. Well, the method we used to use, we had a suspended particulate plastic beads. So they're about tiny plastic beads, they're kind of microplastics, they're about 0.2 microns in diameter. And at a certain pH, you pour your sample in, add some of these beads, adjust the sample to a certain pH. I think it's about pH about 8, between 8 and 9. The metal ions of interest are kind of stick or chelated to the beads. You can then centrifuge the sample. So all the metals of interest then are in this nice little bead at the bottom of the sample centrifuge tube, and you can pour away the interfering seawater off the top. And then all you do is put in some stronger acid onto the beads, and the metals go back in solution, and then you just centrifuge them one more time just to get the beads down the bottom, so you get a nice clear solution, and you can just analyze that nice liquid then for metals analysis, and it gets rid of all those interferences. The new method, though, it saves that kind of preparation step, because when it advances in technology, machines get more and more sophisticated all the time. And so we could actually analyze nickel, chrome, cadmium, and lead on the one machine straight away without this preparation step. So straight away kind of saves all those plastic tubes. There's also an extra test you could do, our chromium, which was a separate method where you get, because of the seawater, you have to do by kind of a graphite furnace method. So they kind of saved all the plastic cups that were used on that method as well. So you can just, lots of saving on the plastic, and also on the nanoplastic beads that were actually used in the preparation method itself. Go on to the next slide, please. This one is slightly different. The first two examples have all been about kind of reducing kind of the amount of plastic you use in the first place. And the reason for the change wasn't always just reducing the plastic. I mean, that was part of it, but not the only reason. One of the main drivers for those is you're kind of saving time, so saving analyst time. So when doing those methods, you can save all that prep stage, and it saves all that kind of time and then therefore money. This one was specifically, we knew we used lots of these plastic syringes, and we wanted to find a way to either not use them in the first place. So the first thing we did is we kind of looked for, is there an alternative method where you don't have to use syringes? So we looked at things like kind of peristaltic pumps and tubing, and kind of filter samples without the need of a syringe. But again, so much tubing would have been involved. It would have been kind of just taking one sort of plastic and reducing it, swapping it for another. So that didn't really work. So next thing we tried was, could we kind of reuse the syringes? Could we kind of send them off to be cleaned and reused? So we tried this, and we sent them away to be washed, and then we kind of tested them. It seemed really good. I mean, the cost would have been a little bit more expensive than we currently use, but you had that kind of benefit of being using them. But unfortunately, we kept experiencing contamination issues. And being a lab where some of our samples may ultimately go to kind of be used in legal cases, we couldn't have that kind of contamination kind of possibility hanging over us. So finally, we looked at recycling. Recycling was something we would ideally be further up the hierarchy chain, but we thought, we'll give recycling a go. But the syringes we use, the kind of picture on the left is the ones we used to use, and this kind of black rubbery kind of a stopper on it. And when we came to try and recycle them, that was virtually impossible. We could recycle half of it, but not the other half. So we went out to our suppliers who supply all our consumables and said, right, can you kind of find us some syringes we can use that are easier to recycle? So they came back with a few alternatives. And again, just to make sure that they were all fine, we did the kind of similar sort of testing. So we tested them for various analytes that we actually analysed for in the lab, just to make sure there's no contamination issues. And then we sent them out to the samplers who actually used the syringes out in the field, just to make sure they were all right for them as well. And the new syringe, it was a lot similar to recycle, and the trials went okay out in the field in samplers. They're not quite as sturdy as the ones we used to use, but they said they were happy to use them. And because it was a lot easier to recycle, this is the one we went with. Again, so saving thousands of syringes from just being dumped into kind of a landfill or being sent off to incineration. So this is a good example, again, where we actually able to do some changes in the things we do, looked out there. In this case, we managed to find something that we could recycle. We got some other examples, I think. I mean, if we put a kind of a paper together of various kind of case studies that we've done, and I think it's available through Sophie. So if anyone wants to get a copy of that, feel free to get in touch, and we shall send out copies. I think that's it for me, Sophie. And this is anything else?
Thank you, Rich. That was brilliant. Really good examples there, and it just shows you practically. Also great with the photos there to see it all kind of there. So yeah, thank you so much for your presentation, and I hope a lot of people got a lot out of those examples. We're going to take a very short break now, just so people can quickly nip and do anything they need to do. So if we come back in 5 minutes time, so let's have a look, it's 11:19. So if we could come back by 11:24, that gives you 5 minutes, and then we'll go through question and answers, and we'll be sharing some further resources and support that we can offer you, and also another opportunity to sign up to a plastic reduction commitment. So take a quick break, do come back, and we'll continue shortly. Thank you. Right, welcome back, everybody. Hopefully you've had just a nice short break there, feel invigorated. So, sorry, I'll just start my video. Yeah, so hopefully you've had a nice short break there. So we've got the opportunity now to have a question and answer session with our speakers. So Martin and Rich, hopefully you're still there, ready for some interesting questions.
Yep,
so
still
yeah,
here.
Great. So for everybody on the line, thank you for staying with us. We've got, if you could please type questions in the Zoom chat. I think a few of you have already asked questions, or you can use the raise your hand function, the little hand function on Zoom. Lizzie's going to kindly pick out some questions from the Zoom chat to start off with. Yeah, we'll try and direct those to either Richard or Martin or ourselves to answer those. So Lizzie, if you'd like to go ahead and let us know what you've found there in the questions. Thank you.
Brilliant. So we've had some great questions throughout our presentation so far. So I'm just going to go back through the chat. I think this was when Martin was presenting, so probably one for you, Martin. So someone's asked, what about plastics used within infectious hazards waste?
They were asking about plastics used for infectious hazards.
I assume so, yeah.
You know, there is no silver bullet here. You know, if they are contaminated, then you can consider a decontamination procedure. We put a decontamination procedure within our lab plastics guide, which we took from Oxford and Suraj and from some other folks who wrote a paper on this. You know, part of it was soaking it in Distill to ensure that it was decontaminated. You do have to look at exactly what you're using, and it does require a bit of critical thought in that sense, you know, in how it can be applied. So there's not one size fits all, but it is feasible. It just depends. And regulation does mean in some places you're not allowed to. You know, if you're in a CL3 lab, category level 3, then it's not really feasible. So that is a limitation that we can't get around right now.
Brilliant, thank you. We've got another question as well. So if I just read out the question, so what about the metrology potential issues with consumables and reuse?
I think that question was about, so I think they were meaning measurement. So metrology, so it's I mean, I would maybe argue that if you're using the same consumable, then it's a more consistent means of measuring as opposed to varying them. I'm not too sure. We would say continue to calibrate your pipettes and scales just so that your units of measurement are still comparable. I'm not sure if that's a perfect answer, but I hope that addresses what they were raising.
Rich, do you have anything to add to that? Or
No, ours is very similar. We have a very kind of strict kind of calibration policy where we go through and we do checks on balances, pipettes, etc. Just doing kind of using distilled water at set temperature and just recording the weights and things. So I think they're very similar.
brilliant, thank you. We've got another question from Val. So is there any data collected that shows the cost and time implication for washing and reusing, for example, Petri dishes? So for example, if there's technical support staff that were doing this, how will it affect their workload?
I'm just going to answer that one because that's definitely the paper that I presented there, was looking literally at Petri dishes and their reuse with the workload. So it just shows that within that analysis, we were looking at Petri dishes to show that you know, the overall emissions were significantly reduced despite the use of the washer and autoclave, and that costs were either comparable or reduced as well. So there is evidence in that. It's in a preprint, but we've sent it to publication. You know, I'm happy to share the data if anybody's interested, and if they want that link, I'll put it in the chat now so people can reference at least the preprint until the publication comes out.
Brilliant, thank you. And we've also got a question potentially for you, Sophie. So do you have lab plastic recycling guidance at the Environment Agency? Our waste contractor refuses to take even clean lab plastics.
Rich, you might know specifically what we've got in our labs on recycling guidance.
Yeah, we tend, not guidance as such, we do have to kind of go around various waste contractors to see who would take certain waste streams. So it is quite often, it can be quite, take up a little bit of time to start with, but once you have a supplier you know will take it, you find it a bit easier then.
Brilliant, thank you. And we've got another practical question in terms of what service do you use for plastic syringe recycling, please?
What service was that, sorry?
Yeah.
Oh yeah, we got a company that's done for our consumables contracts, that they also do a waste contract as well. So although we kind of buy all our kind of consumables off one company, they also do our waste side of things. Well, they got kind of specific ones, and they can do the plastics. So yeah.
Brilliant, thank you. And maybe one for you, Martin. Are there any resources for chemistry labs and chemical manufacture?
It's a fair point that some of the examples probably looked at life science labs, and I suspect that's because a lot of the plastic consumption probably comes from life science labs and tissue culturing, and medical labs as well in clinical settings. But I will say that there are some examples of column reuse, and there are some examples in the consumables guide, which I put in the link above. I put a resources page, which has all of our guides and resources. At the bottom, you'll find our Green Lab consumables guide. We called it a consumables guide because we didn't want it to just be about plastics. So it does look at reuse of other items. There are some chemistry examples in there. I know there's another one that's just escaping me right now, but I would encourage you to have a look. And if we're missing anything, please do let us know, and become a co-author, add your name on there and tell us, and give us some help. So.
Brilliant, thank you. Another very practical question as well from Rowan in the chat. What's the best way to recycle polystyrene?
So we've had terrible trouble with polystyrene, and the only thing we can do is to try to get suppliers not to give it to us in the first place.
Yeah, I would agree with that. For the most part, it isn't recyclable. There are compactors that you can purchase, and some sites will use compactors so that they take up less volume in the trucks for the transport required for disposing of them. Promega has a scheme where you can send back their packaging, but they don't actually recycle it. They compact it for disposal. NEB is the only company I know of that will actually reuse that polystyrene packaging. And it would be great if other companies did as well. But NEB is the only one that I know that is genuine, not just recycling, but reuse.
Brilliant, thank you. We've got another question as well. So when estimating the amount of carbon used to create an item, is there any estimate of the carbon used in the packaging and transfer of that item to?
When we did our paper, I don't know, Richard, if you want to jump in too, but we looked at we used DEFRA figures for the plastics, so that I do believe that includes transportation. I don't believe it includes the packaging. I don't think we looked, it's a good point, but we didn't look at the packaging of single use versus reuse. But actually that would just make a stronger case in some ways for more reuse, because there's packaging that we didn't incorporate in our single use analysis. So actually there would just be more carbon embodied in that loss of packaging. So it's a great point, but yeah, transport, yes, but not, yeah, sorry, go ahead.
Yes, yeah, similar for us. So we got the DEFRA conversion factor, so we use majority of those. And the other things we can do is, if it's one of our big contracts, we try and put it in the front. So you say packaging, we want you to either use packaging that is recyclable or reduce the amount of packaging that comes with an item. So that's kind of up front in our contract at the start.
That's brilliant. Sorry.
Brilliant, thank you. And we've got some more discussion going on about polystyrene as well within the chat. So if you're particularly interested, make sure the chat's open up and you can see that going on. And we've got another question from Samantha. So what do you think about the individual / group pressure on suppliers to give alternatives and offer collections of waste? So Samantha recently tweeted images of a huge amount of Abcam plastic our web has ordered, and found Abcam were quite responsive about changing these semi-plastic anti-foam containers. However, she's still waiting for the change.
Yeah, it's very similar to any kind of contracts we do. We'll try and push sustainability as much as we can within those contracts, and we'll kind of try and stipulate things where we can, whether that be kind of social justice side of things, kind of reducing kind of that side of the contracts, or whether it's kind of reducing plastic or reusables, etc. So we'll try and put as much as that if we can in the front of the contract.
Agree with that. It's a great point. I think just to ask them for their embodied carbon figures whenever you have large contracts. And the tough truth is that some of these companies are so big. For example, Thermo Fisher, that each institution is still small change in how many customers they have. So, but I think what you did, Samantha, in terms of publishing it on Twitter is great, because that definitely gets a better reaction from them than emailing them, and would really suggest people to continue to do that, because that's how they react. That really is what they listen to. You're the purchasers. In some ways, your voice is louder than mine, because I'm just a facilitator. I think you're the ones who they would listen to. So putting that on Twitter is a great idea, and hopefully Abcam can answer quicker.
Brilliant, thank you. Both great answers. And following on from that quite nicely, we've got a question from Laura asking how to convince people, for examples, about take-back schemes if transport also has a carbon impact.
I will say that NEB, when they were looking at the take-back schemes, as I understand it, and I believe this is true for the VWR solvent bottle reuse scheme, is that they use the trucks that they're coming in for deliveries on. So they are conscious of not doing that. And to be honest, one of the bigger challenges that we found is just getting people to take advantage of the schemes, and also the space in stores. Stores end up with boxes, empty boxes, and space is always at a premium in science facilities. So one thing that I saw that NEB are piloting, and they're doing this at our biosciences center at UCL, as well as some others, is having a single truck go around London on one day, collecting all of the packaging at once. So an empty truck that goes, and I believe it's one that was used for deliveries, that goes on a set day, with the idea being that everybody would bring down their boxes on that single day to avoid it piling up. So it's going to take a bit of that type of engagement, but it involves engaging a lot of folks at the same time to do this. So it's not easy.
Yeah, similar for us. It'd be when the trucks do the delivery, we'll get them to take the take backs at the same time. So there's not an extra journey.
Brilliant, thank you. That makes complete sense. And we've got a question from Anne here. So do you know of any schemes for recycling or reusing cooling packs?
Only NEB, to my knowledge, will actually reuse them.
We had the same. We just couldn't find anyone to take them back.
To be scientific for a brief moment, did collect everybody's ice packs, but then they got inundated with ice packs from all of you folks, and it was great that everybody sent them back, but it just shows that a lot of people want to reuse them and recycle them, but there's not a clear solution. So NEB is the only company I know, and they'll only take back theirs for now. So we need more companies to do that type of scheme.
Brilliant, thank you. Got another question, and we must be coming to the end of the question. So if you still got your questions, just quickly put them in the chat. However, this might be one of the penultimate. So does anyone know of any companies who will do reuse of containers for solution refills? We use a lot of cleaning detergents and sterilizing, i.e. Milton, and it would be great if a company was able to take back our containers and refill these rather than sending out a new 5-litre bottle each time.
So I'm not aware of any off the top of my head, but we tend to buy concentrated and then do dilution on site. So, I mean, it reduces it slightly by having a concentrated container that's delivered, and then we kind of dilute that down by a factor of 100, whatever, to make up smaller solutions that we use.
Brilliant, thank you, Rich.
think it's just a great point. I will say that I just saw a company come out, and I can't remember the name, with a piece of equipment that apparently can make media on site. I haven't investigated this, but it is interesting that they are conscious, and their claims were around environmental sustainability. I think somebody shared that on the Lean network. So hopefully more comes out, but I'm sorry, I can't remember the name. I'll see if I can find it now.
Brilliant, thank you, Martin. And if you do find it, just feel free to pop it in the chat. I think we've got our last question. So it's from Jeffrey. So has anyone had success in reducing the number of deliveries of consumables, i.e. grouping orders to suppliers and suppliers delivering complete orders?
Yeah, we have, but again, that's done at the contract stage. I think our PPE supplier was quite a big one. So what we did a few years ago is we'd ask people to, if they got any kind of examples of bad packaging, to kind of let us know in our team. And we kind of used our health and safety reporting system, because it's an environmental and health and safety reporting system. So we got people to report it on there, and then we could address where our problems were. And our PPE was one where they were doing delivery. So someone would order a new, I don't know, a new top or new trousers or something, and it would come in a single package. So now we've got them to hold the stock and only deliver when it's a certain amount. So they'd kind of reduce that kind of delivery and packaging material. So they'd kind of bulk them up and kind of deliver either once a week or once a fortnight, whatever. Again, we didn't realize what the problem was there until we kind of, like people said, you actually kind of have to kind of get that kind of record of what's happening out on the ground. And then when you've got that evidence, then you can go back to the suppliers and say, look, this is happening. What can you do about it?
Brilliant, thank you. Yeah, it's that two-way communication that's just so important to be feeding back into you. Martin, do you have anything else to add?
Just one last thing I want to add, and Rich, you made a great point about putting on the suppliers, and I just think it's also worth pointing out experimental planning. A lot of suppliers have essentially kind of got us addicted to overnight deliveries, and that entails more packaging and more deliveries for small deliveries, and realistically, if we can plan things and consolidate our orders on our side, of course, it makes it easier for the suppliers to reduce the volume of packaging, and et cetera. So it's very much on their side, but it's a little bit on our side to try to avoid relying on overnight. And I know we don't all rely, but it's plan your experiments to see what reagents and consumables you'll need, and try to consult your stores or local procurement manager if you can get them in bulk to avoid too much packaging.
Brilliant, thank you, Martin. I think we've come to the end of most of the questions. There might be a few little comments in the chat, so feel free to answer those if that's applicable. But I'll hand you over to Sophie. So thank you very much for that discussion.
Great, thank you so much for your questions, and thank you very much, Martin and Rich, for answering those so brilliantly, and Lizzie for leading that session. Hopefully that's been really useful for you to get the opportunity to ask those questions. We're just going to move on now to, I'm just going to share my screen again. Just one moment. And so we've got the opportunity now for you to think about making a plastic reduction commitment. So if you'd like to scan the QR code, it's going to take you through to a Google Doc form that Lizzie's brilliantly put together. And there's a list of 10 ideas of things that you can do in your laboratories. And this is based on the excellent, one of the excellent resources that Martin mentioned, UCL have produced with Partners for the LEAF programme. So there's a number of different ideas of actions you can take within your laboratories. And if you'd like to have a look through and tick at least 3 of those, you've also got the link in there also to the email address to email Martin to get in touch about the LEAF scheme. And if you would be kind enough to also leave your details within the fields of the form as well, that would be really useful for us. And if you do leave your email address, it means we can get back in touch with you to share future resources, including perhaps the link to the paper that Martin mentioned. We'll have the final version and any other resources that we can share with you in future. Also, we'd really like to get back in touch and see how you're doing with your journey to reduce avoidable plastics in your laboratory in a few months' time. So I'll just give you a few minutes just to complete that Google Doc form. So thank you very much before we move on to the next section. Also, with all the resources that we've shared in this webinar, please do feel free to share this link with other organisations, with laboratories that you have got contacts in as well. Thank you. Hopefully you've had a few minutes there to take you through to that Google Doc form. If you don't have time to do it now, please do look after the session. But yeah, I find sometimes it's easier to get things done straight away so we don't forget them. So after this, we're just going to quickly move on to a Slido poll. This is our last Slido poll of the session, and then we're going to then just talk about resources and support that we can offer you to help you on your plastic reduction journey. So yeah, that's just moving on to Slido. Just a reminder that actually it's the QR code on the screen, and you can join at slido.com with the hashtag labs. So if you have a look at that, and I'll just make sure I've enabled the poll for you there to stop showing my screen, just one moment. Okay, so that poll should be activated. I'll just put the QR code back up for those of you who need to see that. There we go. So hopefully you can just see that code now. Maybe just log in and fill out that questionnaire. Just give you a couple of minutes to complete that Slido survey, and then we'll move on to resources. Great, thank you everybody. That should have given you enough time just to complete the Slido survey. So thank you for that. It just really helps us to understand and have a look at what the impact of the presentations and the webinar has been for our evaluation, which is really important for our project. So moving on to resources and support. Mentioned earlier in the presentation that this is all part, this webinar was part of a Preventing Plastic Pollution project that the Environment Agency is one of 17 partners. We have a project website, preventingplasticpollution.com, and you'll see from the screen, there's a screenshot there. We've got a number of different things on the project website, including if you click on the resources link, a drop down there takes you, if you have a look at businesses. There's a webinar on plastics in the supply chain that we recorded from the Environment Agency. Gives some tips and some examples about ways you can influence your supply chain. Martin mentioned some of the things you could do to work with suppliers, and so did Rich. So that's a really useful webinar resource. We also have some other tools on preventing plastic at work, pollution at work, and a kind of waste audit tool as well. The West Country Rivers Trust have put together. In that resources drop down, there's also links to educational resources. We mentioned the STEM education earlier, and there's also community resources if you wanted to work or link up with your community. There's other, we post events on here, such as this webinar. There's a news, and there's also a newsletter you can sign up to for the project. And we're also on social media. So do follow us if you want to know more about the project, and the project runs up to the end of June next year to 2023. So just moving on to the next resources. Martin mentioned these, so just kind of reinforcing, I suppose, that University College London have put some really good resources together for the LEAF Sustainable Lab Standards and Tools. A mixture, a bunch of resources and materials as well. And just to remind you that if you want to find out more about LEAF, please email Martin, which is at leaf@ucl.ac.uk. It's great to have all those resources available.
I feel terrible about what's happening. I really do.
The
other
plastic feces picking up on
well, if they haven't mentioned.
Someone just go on mute there, please. Thank you. That's great. And then Martin's already mentioned the excellent lab consumables guide, which is really a brilliant guide, some really good detail in there. So yeah, please do have a look at that. Lizzie's just putting these links in the chat for you as well, so you can access those. Martin's also mentioned the two posters on non-hazardous lab recycling and 10 ways to reduce plastics. Those 10 ways are what the commitment that you just looked at on the Google Doc, which was based on as well. So excellent resources there for you all to be able to use. And really just kind of not much more, I think, left than to sort of thank you all for your time in joining. I'll give Rich and Martin just a quick opportunity. We've got a couple of minutes to share anything else they would like to, and then we'll bring this webinar to a close. So Martin, I don't know if you've got anything you wanted to add before we wrap up the webinar.
I just wanted to say thanks for everybody, to be honest. It's, you know, if anybody has anything else they want to contribute, always open to people adding to those documents. And thank you, Sophie and Lizzie and Richard for putting on today. Much appreciate it. Thank
you. And Rich, I don't know if there's anything else you wanted to add before we put.
No, very similar. Thanks for everyone. Thanks to everyone for attending today. And like I said, that LEAF scheme is really, really good. So I really recommend people taking it on board. I mean, at very least, it just kind of highlights what problems are.
Thank you, Rich. Brilliant. So yeah, thank you for your time today and contributions. Huge thanks to Martin and Rich for your time and your really excellent, useful presentations. And thank you to Lizzie for supporting me. Hope you found this morning useful in identifying some key areas where you can review and tackle avoidable plastics in your laboratories. If you've left your email address when you completed the Eventbrite sign up or when you completed the Google Doc form, then we'll be back in touch with you to share future resources and see how you're getting on with your plastic reduction journey. So thank you very much and wishing you a great rest of your day. Thanks for your time. Take care, everybody.
Thanks very much.